Hello, my name is Takahisa Sanada. Today, I am going to talk about household spend analysis. This is the agenda. After sharing purpose, I will talk about predicted household expenditure data. Moving to data preparation and EDA, I will share my analysis with data treatment, model development, model evaluation, and result. Finally, I will share my conclusion and next steps. Purpose. The purpose of this analysis is to create a model to predict household expenditure. Based on the analysis, we gained these predictions of household data. As you can see here, the graph is centered. Let's talk about preparation. Data merging. The reason for this is to combine data from different sources using a shared identifier, for example TMP-ID, to create a unified dataset for analysis. Next, data sampling. To create a manageable subset by randomly selecting 70% of the training data for model training, reducing computational load. Validation set creation. I created this with 30% of sample. The reason for this is to set aside 30% of the sample data for model performance evaluation and generalization assessment. Handling missing values. Replace missing values in age and y-hat columns with their respective column means to prevent biased predictions. Removing unnecessary columns, for example, LAT, state FIPS, etc. The reasons for this is to eliminate irrelevant columns like geographic, numbers, and numeric data, and personal identifiers to simplify the dataset and improve efficiency. Data treatment with VTreat package. The reason for this is to use the VTreat package to enhance data quality, encoding, and handling missing values, making it suitable for machine learning. Let's move to EDA. First law examination. The reason for this is to gain an initial insight into the dataset by reviewing the first few rows to understand its structure. Summary statistics calculation. The reason for this is compute summary statistics for each variable to grasp data distribution, central tendencies, and variability. Outlier detection. Identify potential outliers in crucial variables in age and y-hat that may impact model performance. Correlation analysis. The reasons for this is to evaluate relationships between numeric variables through a correlation matrix, aiding in understanding variable interactions. Visual exploration. I used the scatter plot. The reason for this is to visualize the relationship between age and y-hat using ggplot to uncover patterns or trends in the data. Data treatment. Variable selection and elimination. The reason for this is removed unnecessary columns, such as LAT, state fibs, TMP-ID, and so on, to simplify and optimize the dataset. Using vtreat for data processing. To apply the vtreat package to process the treating data, which create a treatment plan and ensuring consistent data treatment across various datasets, such as training, validation, test, and prospect data. Model development. Model construction with linear regression. The reason for this is to utilize the LM function to create a linear regression model using y hat as the dependent variable and all other treated training dataset variables as predictors. Variable selection considering significance. The reason for this is to evaluate variable significance using p-values, aiming to identify non-significant variables, such as p-values exceeding 0.1, for potential removal in subsequent model iterations. Model evaluation and results. Evaluation with RMSE. The reason for this is assess the linear regression model's performance using RMSE as the primary metric to quantify prediction accuracy. Linear regression model refinement with p-value based variable removal. The reason for this is to enhance model accuracy and simplicity by eliminating variables with high p-values. First, I did the linear regression with normal one. Then in the model 2, I eliminated the columns which p-value is more than 0.1. Samely, in the model 3, I removed the columns which p-value is more than 0.05. Performance across multiple datasets. The reason for this is measures the model's predictive ability on various datasets, including training, validation, and test sets, ensuring robustness. So, I used the test set because the number 98.30 is the most accurate. Finally, conclusion and next step. The data suggests that the models used for predicting household expenditures are quite similar and not very diverse. This means they tend to produce similar predictions most of the time. To address this, we should explore more advanced models beyond linear regression to investigate issues like collinearity, multicollinearity, and fix any problems that affect the interpretability and functionality of linear models. Thank you for listening.